by forever quantum mechanics infinitist. If quantum mechanics hasn't profoundly shocked you, you haven't understood it yet. Because the theory of quantum mechanics could explain all of chemistry and the various properties of substances, it was a tremendous success, but there still was the problem of the interaction of light and matter. Quantum mechanics brought an unexpected fuzziness into physics because of quantum uncertainty. The Heisenberg uncertainty principle, string theory, does so again because a point particle is replaced by a string which is more spread out. Physics is really figuring out how to discover new things that are counterintuitive, like quantum mechanics. It's really counterintuitive when you think about the complexity of our natural world. Plants using quantum mechanics for photosynthesis, for example, our smartphone begins to look like a pretty dumb object. The mathematics of quantum mechanics very accurately describes how our universe works. What you can show using physics forces this universe to continue to exist as long as you're using general relativity and quantum mechanics. You are forced to conclude that God exists, and relativity movement is continuous, casually determined, and well defined, while in quantum mechanics it is discontinuous, not casually determinate, and not well defined. Quantum mechanics and general relativity are both accepted as scientific fact, even though they're mutually exclusive. Albert Einstein spent the second half of his life searching for unifying truth that would reconcile the two. The scientists often have more unfettered imaginations than current philosophers do. Relativity theory came as a complete surprise to philosophers, and so did quantum mechanics, and so did other things. String theory is the most developed theory with the capacity to unite general relativity and quantum mechanics in a consistent manner. I do believe a universe is consistent, and therefore I do believe the general relativity and quantum mechanics should be put together in a manner that makes sense. It is a curious historical fact that modern quantum mechanics began with two quite different mathematical formulations: the differential equation and the matrix algebra of Heisenberg. The two apparently dissimilar approaches were proved to be mathematically equivalent. For the record, quantum mechanics does not deny the existence of object reality, nor does it imply that mere thoughts can change external events. The facts still require causes, so if you want to change the universe, you need to act on it. One of the main successes of string theory is that it has been able to unify the general theory of relativity, which describes gravity, and quantum mechanics. If we look at the way the universe behaves, quantum mechanics, it gives us fundamental, unavoidable indeterminacy, so that alternative histories of the universe can be assigned probability. Einstein's theory of relativity does a fantastic job for explaining big things. Quantum mechanics is fantastic for the other end of the spectrum for small things. Why do you do calculations using quantum mechanics, even when you are calculating something perfectly sensible, like the energy of an atomic state? You get an answer that is infinite. This means you are wrong, but how do you deal with that? Is there something wrong with the theory, or something wrong with the way you are doing the calculation? In the future, maybe quantum mechanics will teach us something equally chilling about exactly how we exist from moment to moment of what we like to think of as time. The more you study quantum mechanics, the more crazy and incomprehensible it becomes. You truly need a PhD in very high level math and science to understand it at a high level. Quantum mechanics brought an unexpected fuzziness into physics because of quantum uncertainty. The Heisenberg uncertainty principle, while classical mechanics correctly predicts the behavior of large objects such as tennis balls. To predict the behavior of small objects such as electrons, we must use quantum mechanics. If I realize that actually there's quantum mechanics happening around us all the time in some macroscopic, interconnected way, then that doesn't change my perception of it. That doesn't change my interaction with it. It just changes how I view my interaction. There's a lot of things I nerd out over quantum mechanics. I also love Dungeons and Dragons. I want to be an astronaut. Nothing can create all the time due to the laws of quantum mechanics, and it's fascinatingly interesting. The development of quantum mechanics early in the 20th century obliged physicists to change radically the concepts they use to describe the world. Most of what Einstein says and did has no direct impact on what anybody reads in the Bible. Special relativity, his work in quantum mechanics, nobody even knows or cares. Where Einstein really affects the Bible is the fact that general relativity is the organizing principle for the Big Bang. One of the most exciting things about dark energy is that it seems to live at the very nexus of two of our most successful theories of physics: quantum mechanics, which explains the physics of the small, and Einstein's theory of general relativity, which explains the physics of the large, including gravity. I finished up my graduate degree in quantum mechanics, but underwent a bit of a personal crisis, recognizing that I didn't want to do that for the rest of my life. I was too abstract, too far removed from human concerns. I've been a big astrophysics nut since I was 12. I have always had a real soft spot for the bizarreness of quantum mechanics, but I gave up on being a scientist in high school. I'm just not good at math, rap. Before the discovery of quantum mechanics, the framework of physics was this. If you tell me how things are now, I can then use the laws of physics to calculate and hence predict how things will be later. The most important single thing about string theory is that it's a highly mathematical theory, and the mathematics holds together in a very tight and consistent way. It contains in its basic structure both quantum mechanics and the theory of gravity. That's big news. The math of quantum mechanics and the math of general relativity, when they confront one another, they are ferocious antagonists, and the equations don't work. Now, what that means is that there is a fundamental indeterminacy from quantum mechanics, but besides that, there are other sources of effective indeterminacy. No one intuitively understands quantum mechanics because of all our experience involves a world of classical phenomena, where, for example, a baseball thrown from pitcher to catcher seems to just take one path of the one described by Newton's laws of motion, yet at a microscopic level, the universe behaves quite differently. The birth of science as we know it arguably began with Isaac Newton's formulation of the laws of gravity and motion. It is no exaggeration to say that physics was reborn in the early 20th century with the twin revolutions of quantum mechanics and the string theory of relativity, rapping infinitely for eternity, scientifically.